So in this session, we're gonna discuss about input and output. Uh, so before we jump into file input and output, let's set up some few rules that will make our all your input and output code cleaner and safer. First, there are two input output families in Java: byte streams and character streams. So byte streams are basically input and output streams. Those move raw bytes. Use them for binary data, images, PDFs, zipped files, anything that isn't plain text. Then we have character streams, which is text. It's like a reader or writer. These move characters, use them for text. So if you ever need to cross that boundary, say you have bytes coming in, but you want characters using bridges. Use bridges. You can use bridges for that. Like we have input stream reader, which is bytes to characters, and output stream readers, characters to bytes. So when you use these, always specify the char set. That brings me to rule 2, which is encoding. If you're reading or writing text, say UTF 8 8 out loud in your code, don't rely on the platform default. Good examples are good examples are files dot new buffered reader path standard char sets dot UTF 8. This. So yeah, this is one good example, and another one is for writer, and then we have a new input stream reader standard char sets So these are few good examples for encoding if you're writing or writing text. So and next we have resource safety. So streams are operating system resources. If you don't close them, you can leak file handles. Use try with resources, so Java closes them even when an exception happens. The pattern looks like something like this. Try var reader equal to files dot new buffered reader, and then path, and then UTF 8. Yeah, 8. Then your read lines. So when try block exits, the reader is closed automatically. No extra final block needed. So that's resource safety. Next we have buffering. So buffering, reading one byte or one character at a time is slow. Wrap your sources syncs with buffers. For text, buffered reader, buffered writer. For bytes, it's buffered input stream, buffered output stream. These classes read and write in chunks under third, which is dramatically faster. Uh, let's think about example. Uh, you can code in under a minute later. So you want to read a text file um, of names and print them with line numbers. You could try this try var in is equals to files dot new buffered reader path dot gets and your file name, which could be like names dot text, and then your you have eight, and then you close it. So inside the loop string line, you could write like int n is equal to 1 and print n plus plus, and so that's buffered UTF-8 and safely closed. So that's a simple example that you could try later. Next up is paths, which is nio.to API, which is it's clearer and safer. It builds paths with paths.get data. Like an example is path paths.get data grades dot text file. This handles separators for you. Checks the existence with you can check the existence with files dot exist path. If you need parent folders, files dot create directories, path dot get parent. That's a way to find if you need a parent folders. So a quick note on relative and absolute paths. A relative path is like data grades dot text file is resolved against your program's working directory, often the project root when run from an IDE. An absolute path starts with from the drive, like C drive or home. Try to avoid hard-coded absolutes in assignments. Keep things relative so your code runs on any machine. About new lines, different operating systems use different new line sequences, like /r /n on Windows, /n on Unix, Mac OS. When you print, prefer %n in printf, or just write /n with writers. Java will handle it well enough for our use. So if you're formatting with printf, use this. It's a portable choice. So pick the right family. Bytes for binary, reads and writers for text. Always specify UTF-8 for text, and use try with resources so streams close automatically. And buffer your input and output, buffered reader, writer, or buffered input output streams. Use nio.to API paths, files, and check existence and parents. New line, %n with printf or /n with writers is fine. If you follow these rules, the code you write in next sections, formatted output, file input, file output, will be reliable, fast, and so yeah. So those are the basic rules. So first topic is output and input streams. So we're gonna make sense of Java's input output by splitting it into two simple lanes, then showing how they stack together in real code. First idea, we have two families. Lane one is byte streams, which is input stream and output stream. They move raw data, use them for anything not guaranteed to be text, like images, PDFs, zip files, serialized data. Core method you'll use is int read. Let me actually. These some of the core methods are int read. It reads 1 byte and returns -1 at the end. Another one is byte buffer. It fills a chunk. It's faster, and we have void write. Let's say int b, and we have a void write. I'm very bad at this. Byte buffer, and also we have a flush. It pushes any buffered output, and then we have a close. So this is lane 1. So lane 2 is character streams. Reader and writer, they move characters and understand text encodings, use them for text files, logs, CSV file, JSON files, anything human readable. They have parallel methods like read char, write in string char, close. So next we have bridging with bytes to text and vice versa. If you've got bytes but you want characters, wrap with input stream reader bytes to characters. If you and output stream writer characters to bytes. So when you bridge, always set the char set, and for this class say UTF-8 explicitly. Let's say something like this. New input stream reader in standard char sets .utf/8, and the same thing goes to writer, but it's output. So if you don't specify, you gamble on the platform default. So yeah, these are used to bridge between character and string. So next we have layering pattern. Layering pattern. Most real input and output is done by stacking small building blocks. Like first we have file, it could be a file, socket, array. Then it goes to buffering. Buffering is basically by using buffered input stream, buffered reader, buffered writer, and then it goes to code C, which is writer reader for text with UTF-8 or stay as byte streams. Then it goes to convenience, which is basically PrintWriter for printf style output. So think of it like plumbing. Source, then a wider pipe. Wider pipe is your buffer, and then a translator if you need text. Then nice facets to format output. So yeah, that's the basic idea. So a small example is if you're trying to read bytes from a small file and count them, then write a few bytes to a new file using try with resources so you don't leak handles. First, you read the bytes. You set the path to input bin, open with files dot new input stream path that's already on an input stream, and wrap with the buffered input stream for speed, and then loop read byte into smaller buffer, say like 4 KB. Accumulate the total until you hit -1 and print the final count. To write, you set the path like something like output.bin and open the output stream with files dot new output stream, then your path. Wrap with buffered output stream. Write a small byte array, use flush, and then done. It shows the byte side of the world clearly. If it were text, you would open files dot new buffered reader, your path and UTF-8, and loop lines, or wrap the output in a output stream writer, maybe a PrintWriter to get printf. So that's a simple example to get started, and few things to keep in mind is forgetting to close streams. You fix that by using the try with resources, so Java closes them automatically even on exceptions. We have another thing is mixing bytes and characters without char set. So the symptom for that is weird characters. You'll see weird characters in the output. The fix is use crossing bytes, crossing byte, like always specify UTF-8 with input stream reader and output stream writer, or files dot new buffered reader, new buffered writer. So yeah, and the other thing is reading and writing 1 byte at a time. The symptom will be slow input and output. You wrap with buffered input stream, buffered output stream, or buffered reader, buffered writer. Use chunked reads and writes. Yeah, that's how you should be. Next, we have output formatting. So let's talk about something that's instantly makes your programs look more professional, which is formatted output. You already know how to print things with system.out.println, but once you want your data to line up neatly in columns, for example, an ID, a name, a GPA, that's where formatting comes in. The core tools for this is Java gives you 3 main ways to format: system.out.printf, string.format, and the formatter or PrintWriter class for writing formatted text to files. They all share the same format language, which looks like which could look like this. Percentile D for this is for integers, and this is for and this is for floating point numbers, and this is for strings. This is for new line. The portable version of this one, but yeah, you could use that. You can also set precision and width. For example, it could be like this, f for 2 decimal places, and let's say 8s. It reverses 8 spaces for a string. It's useful for column alignment. So imagine you're printing a little grade report. you could write something like this: print system.out.println, it's a printf, and percentile. So yeah, this is something you could write. This means so this part, left align the integer in 5 spaces, and this one, left align the name in 10 spaces, and this one, right align with GPA in 6 spaces showing 2 decimals, and this one finally, we have new line. So you can use you can also use this one instead of that, but yeah, so it works on all operating systems. uh, the result is clean, tabular layout, IDs, name, ID, IDs, names, GPAs all line up no matter how long they are. So you can do the same formatting to a file using PrintReader. Create one call printf, just like with the console, and it's great for reports, logs, where you want your columns to stay consistent. Um Next is local matters. By default, Java formatting uses systems local, which might use commas instead of dots for decimals. For example, in many European settings, that means 3.91 could show up as 3,91. If you're grading, or if you're comparing numeric output, uh, local dot set default, let me actually write it. Local dot set default uh, dot us. Yeah, you could use this if you're comparing numeric output. You could create your formatter PrintWriter with local.us to keep it consistent. Uh, some of the things to avoid is using uh, /n instead of uh, yeah, percentile n. Percentile n adjusts automatically to Windows, Mac OS, or Linux new lines, but anything else you have to use this /n. Relying on another thing is relying on default local. So use local.us for stable decimal points when you test, when it involves numeric output, and forgetting to flush. So when you're writing to file or socket, call flush if you are keeping it open. If you close it at the end, Java flushes automatically. um, yeah, that's about output formatting. Next is streams using strings. So now let's look at the smaller but really useful corner of Java input and output: string based and memory based streams. So these are great when you don't want to deal with actual files but still want to test or process data the same way. Uh, we have in-memory input and output, which is normally we read from or write to files, but Java also lets us to do that entirely in memory using special streams. For text, we could use StringReader, which reads characters from a string, and StringWriter, which writes text into StringWriter. You can think of these as a fake file made out of a string. They're perfect for situations like I have a block of CSV text in memory and I want to parse it as if it were a file. For binary data, you got byte array input stream and byte array output stream. These read and write bytes stored in an in-memory array instead of a disk. So when you're done writing bytes, call dot to byte array or dot to string. So to get the results back as usable data. So typical use cases is testing without files. So if you're writing a method that reads from a stream, you can pass a string reader instead of making a temporary text file. And another use case is building up content without saving. So you can write everything to a string writer, inspect it, and then dump it to disk or send it over the network once you're ready. And encoding and decoding binary data. So byte arrays are perfect for temporary staging of images or serialized objects in memory. So yeah, like imagine you have let's say you have a one line of CSV data, for example, Avery, GPA is 3.9, and a senior. You can feed it into a string reader, read each token, tweak the GPA, and write the updated line to a string writer. So when you're done, call toString on the writer to get a new line. No files, no cleanup, no clutter. Everything happens in memory. So this is especially handy when testing parsing code or building quick transformations. So again, we have a couple of things to remember here. Forgetting the char set when converting bytes to strings or strings to bytes. Always specify standard char sets .utf-8. Without it, you risk weird characters or data loss when converting. And using plus in loops to build large strings. So that creates new string objects repeatedly and wastes memory. So use StringWriter or string builder instead. Both are efficient and designed for that pattern. And mixing up binary and text. Don't feed text into a binary stream unless you really mean to. Use the right tool for the right data type. And the next topic is file input. So alright, let's talk about reading files in Java, which is a skill you'll use constantly in real programs. So when you move from printing to reading actual data from files, the goal is to handle text safely, efficiently, and clearly without creating bugs that are hard to track down later. So the classic approach is file reader plus buffered reader. The traditional way looks like this. You open a file reader, wrap it in the buffered reader, and loop through each line with read line until it returns null. It's simple and works everywhere, but these days there's a slightly modern way to do it. That's where NIO.2 new input output comes in. So the modern approach is the newer Java input and output APIs under java.nio.file make reading files much easier and safer. You can read line by line using this line of code. Files dot new buffered reader, your path, and then standard char sets dot utf-8. Or if your file is small, you could use something like files dot read all lines and your path. It's simple. So which gives you a list of all the lines at once. So you can even use line files dot lines path to get string which lets you filter, map, and process lines using stream operations. Really useful for larger or structured files. And path handling. So handling paths properly. So always use path and paths.get instead of hard coding file strings. For example, path p is equals to paths.get data grades.text. That works across all operating systems because it handles the separators for you. If you're not sure the file exists, check files dot and give a clear message if it's missing. Don't assume your program's working directory is what you think it is. It's one of the most common student bugs. Yeah. So parsing the content. So next we have parsing the content. So when you read lines, you often want to trim spaces, ignore blanks, skip comments. A typical pattern looks like first is read a line, trim it, skip if empty or starts with bound symbol. Otherwise, split it. For example, a CSV. For example, for a CSV line would look like this: string parts is equal to line dot split. Then you can parse the parts into numbers, objects, and work with them. So example you can imagine is, say you have a file called grades.txt with lines like Alice, 90, Bob, 85, Carol, 95. You'd open it, read each line, split by comma, convert the grade into a number, add them up, and print the average. So if the file isn't found, don't crash with a stack trace. Show a friendly message like system.out.println file not found, and p dot to absolute path. So that's something like that would be good. So yeah, and a few things to avoid. So I'm assuming the file is in your project folder. So the working directory can change depending on how you run the program. Always print out the absolute path for clarity. And reading huge files into memory. So if the file is big, don't use read all lines, or use files.lines instead, which reads as it goes. It's good when you're working with big files. And ignoring exceptions. So don't just catch IO exception and do nothing. Always log or print a helpful message. Yeah, that's about file input. Next we have file output. So now that we have covered reading files, let's talk about writing files, or as Java calls it, file output. So this is where your program actually produces something, it could be a report, logs, saved, game states, anything that should live beyond your program beyond your program's run. So let's talk how to do it safely and cleanly. The classic approach here is file reader plus buffered writer. The older but still very common pattern for writing is first file writer, the basic writer to a file, and then buffered writer, which wraps it for efficiency, and then print writer, which adds the convenience of print and printf methods. So most people these days just use PrintWriter because you can write formatted formatted text directly. Uh, Something like this: out dot printf id name id comma name. So this is simple, it works, it's readable and handles line breaks properly across platforms. But the modern way we have here is again nio.2 the files API. So if you prefer the modern style, you can use files uh, files dot write your path lines comma standard catsets dot utf8. Yeah, you could use this to write a full list of lines at once. It's great for small reports or logs. The nice part is that this modern API lets you control exactly what happens. Like, do you want to overwrite the file or append to it? So you can specify these behaviors with options like standard open option dot create append or truncate existing. Uh, and the difference between overwrite and append is by default most write operations overwrite the file. If you open a file writer or use files.write without append mode, you'll lose the old data. If you want to add to the end of the existing file, be explicit. You could say something like new file writer report dot text file true. True is basically the append mode. Always make that decision consciously. Overwriting by accident is one of the most common file output mistakes. Yeah, that's about yeah append versus overwrite. Next we have next we have directories. So creating directories, this is about safety and reliability. So there are few more habits to build early on, which is creating parent directories first. So if your path is something like data reports report.txt, that data reports folder must exist before writing. You can ensure that uh, like by writing this line files dot create directories uh, and path dot get parent. So yeah, this is one way to ensure that your folder exists uh, and flush and close properly. So always close your writer or use try with resources block. This ensures everything in memory always gets written out. Forgetting this can leave you with an incomplete or blank file if program exits early. And we have atomic writes. So for critical files like configuration or save data, a safer pattern is to write to a temporary file and then rename it when done. That way you never leave half written file behind if something goes wrong mid write. So an example for this is, imagine we are writing a simple grade report file called report.txt. We write a header line followed by formatted rows for each student. Let's say we have two students and with two GPAs obviously. Then we show what happens if you run it again with and without append mode. One version overwrites the old file completely and the other adds new lines below the existing content. So that's a good example to experiment and see how it works. Some of the things to avoid is accidental overwrite, so forgetting to set append mode, and missing directories, so forgetting to create folders before writing, and forgetting to flush, so leading to missing or partial data. So these seem small, but in real world they're the difference between reliable code and hours of confusion. So yeah, that's about this topic.